A charged particle of mass m and charge minus q is traveling through a vacuum at constant speed. It enters a uniform magnetic field of flux density b. The initial angle between the direction of motion of particle and the direction of magnetic field is 90 degree. So if you want to draw a visual diagram, how would you draw it? A charged particle of mass m and charge negative, so it can be electron. Now let's imagine our magnetic field is over in this direction and the particle moves in this direction. So our current will be in this direction. They are perpendicular to each other. And then a force will actually apply over here, which is normal to the current and magnetic field. Now the question is, explain why the path of the particle in the magnetic field is the arc of a circle. Right, interesting question. So if you look at this now, the particle moves, right? So it will form arc. Why will it form the arc? We can say that the force, right, not the force. Let me explain it to you first. When you're talking about an arc of circle, that is circular, we're talking about a circular motion. See, if a particle moves in this direction, then from here on it will move in a circular arc. There will be a force on the particle that acts towards the center. Which force acts towards the center in? That's the centripetal force. And centripetal force, which force is providing the centripetal force? The magnetic force, due to the magnetic field, is providing the centripetal force. Right, and we can and yeah, the direction of motion of the direction of the particle, right? Direction of the particle of motion is perpendicular to the field line. So it's pretty much a motion question. So what we can write? We will write force due to magnetic field is constant and it is perpendicular to direction of motion the radius of the arc is r. Show that q and m for the particle is given with the expression. So as I have explained further that our centripetal force is equals to our magnetic force. The equation of the centripetal force is mass velocity square over r. It came from, we know, force is equals to mass into acceleration. The centripetal acceleration is velocity square over r. So we'll write that. And the magnetic force acting on a charged particle will take a single charged particle. It is magnetic force equals to BQV, where B is the magnetic flux density, Q is the charge, and V is the average drift velocity. You will equate this equation. Alright. The velocities can be crossed out. We can write mass V over R BQ. We can further write Q over M V BR, and we have shown that